Welcome, everyone. Thanks for joining us with a great lineup of discussants again today. This is remarkably the 25th episode of Coffee with EMBL. So to everyone who's here for the first time, a warm welcome. To everyone else, welcome back. Coffee with EMBL has established itself over the last 3 years as a fantastic forum for bringing together EMBL alumni, EMBL staff members and friends of the EMBL from around the world. And you can see that also today. We have people from many continents and different countries joining, over 120 people registered. And this is great that we bring this community together and use it as an opportunity to learn from each other and explore topics of importance. And what could be more important than how AI is impacting our society? So today, our topic once again is artificial intelligence and how it's affecting our society, how it's changing our lives, and how it's impacting our work and our research. Whether you're a scientist or working in almost any other sphere of activity, AI is something that really is going to impact on all of our lives. We talked last time about the ChatGPT and large language models, and how quickly that really has developed. For people not in the AI machine learning field, it's really remarkable that it seemed to come from nowhere and suddenly just demonstrate this almost magical capability with language. It's impacted so much that I'm now hearing people use the expression ChatGPT moment to refer to other fields of endeavor where there's a sudden awakening of awareness about what's possible. And it's been one of the most rapidly accessed and rapidly impactful technologies I think we've seen ever. But AI, of course, transcends way beyond only language models. And we're going to be talking today about some of the other ways in which AI is also impacting our society and our lives, and extending into the ability to create and manipulate images, and also to write computer code. And then we're very interested in how this is affecting our society. And this is really the structure and the main topic of today's talk. Just before we start with that, we thought it might be interesting to just give a couple of examples. Okay, well, we can do this first, Nushi. We can do it in this order. We also wanted to take a poll for the people who are joining us today. We're going to have one poll at the beginning, and then we're going to do it again at the end after you've listened to the discussion. So we are all aware that in a very profound way, perhaps analogous to the way the Industrial Revolution changed our societies forever, AI seems to be very rapidly changing our society. But the big question is it going to make our lives better? That's something that's currently dividing opinion, but Noosh has put online a question. So it's a binary choice. Just please select yes or no, and then we'll see what the audience thinks about that. Okay, while people are still finishing voting then, Noosh, perhaps you could just put up perhaps the first image of the dog. Right, so this is just one example where some of you may be very familiar with this, others less so. But one of the truly remarkable things that is developing so rapidly, this is an image I'd love to say I created, and I created it by simply asking Stable Diffusion, I believe this was, to create a picture for me in the style of an impressionist painting of a dog in a field of flowers. And, you know, within less than a minute, this is the image that it generated. And, you know, this is really quite astonishing. That ability to turn language into images is sort of mind-blowing in a way. Certainly it was for me. The other thing that I think is truly mind-blowing, you can not only generate more artistic images or designs, it will also create photorealistic images. Here's an example that Boyan provided from his own interactions. And this is really just showing also the remarkable rate of improvement, where he asked Stable Diffusion, I believe this was also, to create a photorealistic image of a raptor catching a fish. I think it was an osprey catching, or a fish adler catching a fish. And what we're seeing between the left and the right is just the difference in the quality of the image it would generate after improvement. So this is a technology that is evolving and improving with astonishing speed, possibly exponential rate of improvement. And these abilities have far-reaching implications, potentially for the better, but maybe also with some negative consequences. So Noosh, if you'd like to show us the result of the poll.
So basically, yes, 82% of everybody here said that AI will make our lives better, and only 18 said no. Should I stop sharing?
And what is the numbers that we have? Sorry, because it doesn't say the N, we are scientists.
62 people out of 76 said
okay.
Yes, and 14 out of 76 said no, it's not going to make our lives better.
Okay.
Maybe those are the 14 to start with. Anyway, I'm going to stop sharing.
Okay, that's a very interesting result. I wonder if we would have had a different result if we had an audience less full of scientists. But I'm very encouraged that, like myself, most people thought it was going to make our lives better, and yet the recent focus in a lot of the media has been talking about existential threats from AI and how this is going to either destroy humanity entirely, or perhaps less dramatically, simply increase divisions in our society and disadvantage people. So really with that thought in mind, I'd like to introduce Lucia. Would you like to introduce yourself? Lucia is the EMBL Bioethics Manager and Lead for Science and Society at EMBL.
Yeah, thanks, Angus. Yes, so I'm the Bioethics Manager. I've been at EMBL about 4.5 years now. By no means an expert in AI, but actually have origins as a lawyer. But I guess that applies to many others here. We've just had to start thinking about these topics and how it affects EMBL, how we deal with it from a governance perspective, and also how we engage with the public on this topic, and particularly given the fear and the fear-mongering that you mentioned at the start.
So Lucia, were you surprised at the outcome of the poll?
No, I think it's pretty consistent with the sort of feedback we get, and I guess this is maybe more of a closed audience to some of the public events we run, where we do have, I suppose, more fierce discussion and debate. But what you mentioned in terms of the existential threat, it's funny because I tried to just Google AI and hit news, and those are the first 4 or 5 stories that come up. Particularly one from the New York Times this morning talking about the societal risk being on a par with pandemics and nuclear wars, which I think is quite a bold statement. So yeah, we get that it's something that people are frightened about, and there's a bit of panic, I should say, about the speed of development there.
And do you feel that is largely a fear of the unknown? People are often more frightened of things when they really are not sure what it is and how to assess the risks involved with it, or is it is the fear a lack of confidence in how it will be managed or used? There's a lot of concern about the lack of regulation, for example.
Yeah, sure. I guess maybe my answer is a bit nuanced, because we think a lot about research ethics and governance. And so, the kind of feedback we've been getting is that the fear is more about, the horse is bolted, regulation isn't sufficient, it's outpaced the development, the existing laws and regulation that exists around many other technologies. So, everybody needs to step up and, throw everything they have at AI and see how they respond to it. So that's the kind of angle that we've been getting, I think, a lot from the public response.
And how have you gone about addressing these issues within EMBL? Is there a specific committee that's attempting to, or a group that is trying to assess? Because one of the things that definitely I think is particularly hard to cope with is the pace and the rate of change. What was possible last year is very different to what's possible now, and I assume very different to what is going to be possible in 6 months or 12 months' time.
Yeah, absolutely. I think, I think there's actually a more of a technical working group on AI, but, from an ethics perspective, we've also had to add a new stream as of last year. So, ethics more traditionally is human, animal, also environmental ethics to a certain degree. And now we've got to think about technological ethics, and that's specifically AI and machine learning too. Not least because of the big funding questions. Every single grant application now has a big questionnaire, including all the, EC grants. I've got a whole page on any aspect of a project that has anything to do with AI or machine learning, where, people are forced to think about the potential worst case scenario societal impact. So that's quite interesting. We've had to start producing precedents and guidance on those things, which we hadn't thought about before. We also have established a new external advisory board, but we've had to do that to think about getting advice for those issues where there isn't any external regulation or guidance, and to get experts' opinions from a range of backgrounds. So not just lawyers, but also philosophers. I think we've got a historian on there. We've got, kind of people who think about this in a social context, to be able to throw those questions at them and say, hey, where do we start with this? So I think, yeah, we've had to do a lot in the past 12 months.
There's a lot of great questions coming in the chat, and please do put questions in the chat that we can try to discuss with the speakers, or if there are very specific points you'd want to make. I mean, we will be focusing on a lot of the positive aspects of AI and the way it can enrich our lives. There's always something of a yin and yang element, and I see Niobe Santama asking the question that I think many people have in their mind, which is, what about fake news? Or let's translate that to fake images. I would share with you, Lucia, since you are a lawyer, and I have to be very careful what I say, but I have some of my least enjoyable experiences in my professional life was participating as a sort of expert referee in a number of different universities who identified cases of alleged fraud. And they needed to bring in people to, to advise and to say, was it a fraud? Was it? And these have, I'm not going to talk about any of the details or locations. One thing that I would say was a common theme in almost every one of the cases I investigated was, at some point they involved images which were manipulated in some way, but virtually every image is some sort of manipulation. And very often people said, yeah, I did do that, but no one told me I shouldn't do that, or that I wasn't trying to deceive anyone. So now that AI puts new capabilities and technologies in our hand, it's even more, it's not just a case of Photoshop duplicating and inverting an image that you're saying, but it can actually generate de novo an entire image. How do you deal with it? Do you provide education or advice to the scientists and students and postdocs working for the EMBL on what they can and can't or should or shouldn't do?
Yeah, good question. I think that's the aim. I mean, it's really difficult to balance that sort of need for regulation to make sure all the risks are captured with innovation, which is what EMBL's about. But we are trying to do that. We've also, as you mentioned, had to think about training. We've got a new ethics academy which focuses on that, even internally within EMBL, but also hopefully externally. I guess the education is an important part of that. We also try to provide really interesting case studies and that evidence-based information about what's in and out of scope. But those, we're building those ethical guidelines at the moment, which is hard to do because there's obviously not a lot of precedent either in some areas. In others, it's a little bit more obvious. So, I think for us internally, the most important thing we can do is carry on having those discussions, debates on the topic, seeing what we think, where the guidelines should exist, speaking to our new expert advisors, but also having that increased, culture of transparency, that we can talk about these topics and address any concerns, so we don't accidentally end up in the field of misconduct, as you mentioned, inadvertently, by people not having that information.
The EU are becoming active in trying to regulate this, and there's a nice link to the EU AI Act Is this something you're familiar with, Lucia, or have any?
Yeah, that's right. I mean, we're talking about the European Parliament bill. Is that what you're talking about? And yeah, it's interesting. They've got quite a lot of detail in there in terms of, you know, what they consider 4 levels of risk, minimal to unacceptable, I think. So perhaps we can take some of that and see how we might apply that internally to guidance and policy. But again, they've done a lot also to what they call, you know, this balance of regulating risk versus stifling innovation. You know, if it's too narrow, again, you miss out on identifying harm, and if it's too broad, then you stifle innovation. So they've got some nice tools for us to work with there. Yeah, and it's just I should say, they seem to be popping up everywhere, these guidelines on AI.
So if I can jump in, I wanted maybe a comment and some additional comment from you about that. I wanted to just comment that, I mean, I've been looking a bit in that regulation, and it is very tied up to the privacy issue, because of course in Europe, you know, the privacy relative to the States, for instance, is meant in a different way. And so I see most of the regulation is now dealing with cameras that can use AI to, you know, transform the images and attach meaning, profiling, and all these things. So, I mean, have you thought a bit about these? I mean, is something that is...
Yeah, I think, you know, we have an internal group now which pulls all those data, kind of governance experts, legal, into one group to think about those topics. And you're right, I think the focus is very much more on the health aspect, policing, maybe insurance, you know, how is this going to be used to your detriment? I would argue not too much on the science side, so perhaps there is a bit of a gap there for us to think about how it could impact us. Yeah. So yes, we're definitely thinking about that data aspect.
No, I was actually quite struck because it's a different style, right? The Americans were coming out with a lot of calls for, you know, caution, and the Europeans are taking a regulation that is there of privacy and trying to build some infrastructure, legal infrastructure on that. But the other thing that I was thinking while Angush and you were discussing is actually, you know, this could be the negative sides of, you know, image algorithm. Of course, there are a lot of positive sides, right? And in science, I think Boyan has some examples of how images and artificial intelligence applied to images can be actually positive for science, to see things that you cannot see otherwise. So maybe, Boyan, you want to jump in and tell us a couple of examples of that in your work?
So yeah, thank you very much for this invitation to speak here. I must say that I was a little surprised and hesitant at first to speak here because I'm also no AI expert, but probably as we were discussing, this is an illustration of how nowadays it's becoming increasingly difficult to avoid dealing with the AI, even if you have no intention of doing so. And what you mentioned, one project in which I have used AI in collaboration with other colleagues involved precisely not image generation in this case, but image analysis of real biological data. And that was linked to the evaluation and analysis of metastasis. I don't know, should I actually say perhaps first something about myself? We were invited so I was a pre-doc at Tembo starting in the late 90s, actually at about the same time as Thomas. And then went on to do postdocs in other institutions in Germany. And for the last 15 years, I've been working in the area of cancer research, first at the University of Gießen and now also at the medical faculty in Mannheim. And this one major question in the field of cancer research relates to metastasis. So nowadays, if a patient is diagnosed with a tumor, that's not necessarily the grim news that it used to be in the past, because many tumors can be removed or kept under control for a long time through surgery or different therapies. But the real problem usually occurs when this tumor spreads throughout the body, forming secondary tumors that we also call metastases. And those are much more difficult to operate or to target with existing treatments. And despite of this huge clinical importance of metastasis, until we started the work that I'm going to describe, nobody had a real complete understanding of how cancer cells spread throughout the entire body. Because there were two reasons for that. One was that suitable imaging technologies were not developed that could show this with sufficient resolution. And this particular step had been resolved around this time, at least in simpler models like mice, by a group in Munich with whom we initiated the collaboration. So they had developed a technique to make a whole mouse transparent, completely transparent, and image all the metastases to single cell resolution. But by solving this technical challenge, they created another one, namely that each animal generated huge amounts of imaging data in the range of dozens of terabytes for a single mouse. So the challenge was to analyze these data, and the techniques that were available at that time would either have been very unreliable or would have taken months of human work for every animal. So basically they teamed then with another group that had AI expertise to create a deep learning model that would automate this process. And when this model was complete, it could analyze an animal in less than 15 minutes. And perhaps I could illustrate this with a little video that I asked Renush to share with us. So this is an example of such a cleared mouse. So the entire animal from head to toe has been rendered transparent, and all the tumor cells, so the larger magenta structure that you see at the lower part of the body, that's the primary tumor. And although it's not very big, it has already spread to hundreds of other locations throughout the whole body. So the main organs that are targeted by metastases are segmented in blue, and you can see that we can detect metastases of very different sizes. Some are clusters of multiple tumor cells, but we can also detect individual single tumor cells in every region, every organ of the entire mouse. And in addition to just visualizing this distribution, we also looked at the targeting of such metastases with specific drugs. In this case, it was a monoclonal antibody. And we could reveal that many metastases are targeted. These are the white ones that you see here, but some remain unaffected by these drugs, and they could be the source of problems in the future. So
Bojan, so just to understand the role of AI here, so what do you think AI could enable here? I mean, is it a matter of you couldn't see it without? Is it a matter of there's too much data and you cannot possibly humanly sort this data, so you need an algorithm to do it there? Is it faster? I mean, just to give a sense of where is the giant leap here. Of course, you know, it's fantastic that you can see this in a real animal, and for researchers, this is wonderful, because as you say, you know, looking at the travel of the single cells within an organism is incredibly complex, considering that the organism is not transparent and so on and so forth. So, but what is the advantage of the AI here?
So AI did not necessarily enable visualizing something that could not be seen before without the use of AI. But as I mentioned, if one attempted to do that throughout the whole animal with the existing techniques, we had some data that show that either this would be relatively fast but very imprecise, or it could be similarly precise as the AI model, but then it would take many months of human work. So it tremendously increased the efficiency. Essentially, it made a practically infeasible project a matter of routine, because a single animal could then be analyzed within less than 15 minutes, as I said.
So the hope is perhaps, of course, you know, we cannot clear, you know, humans to do this analysis, but perhaps some of the algorithm could also work in detecting things on a human sample. And connected to that, I know you have a different science story that is more related to AI in human patients, right?
Yes, so this one is not so directly related to imaging, but perhaps just to finish off and to segue from what you said, we still cannot clear an entire human, that's correct. But the same group with which we collaborate has already achieved the clearing of human organs, like including complete human brain or human kidney, that was published recently. And again, this relied very heavily on the use of AI models because human organs are even much bigger than even a whole mouse. So their work essentially is nowadays impossible without the use of AI. And another thing which would have been impossible without the use of AI, and in which I have also been involved through collaborations with groups actually in Heidelberg, was the design of classification system for brain tumors. So brain tumors are relatively rare in adult people, but they're the most common tumors in children, which makes them very relevant clinically. And in addition to that, they're very diverse and their diagnosis is very complex. A trained neuropathologist must analyze many different histological and molecular markers to produce a diagnosis, and even then, expert neuropathologists often disagree about the diagnosis of many brain tumors. And in this collaboration that I mentioned, we aim to design an AI-based, machine learning-based approach to improve this diagnosis, and that took as a basis certain chemical modifications in the DNA of the tumor patients, namely DNA methylation patterns. And it turned out that on this basis, a machine learning algorithm could be developed that reliably and reproducibly classified more than 80 different brain tumor types, which is more than a third of the tumor types that exist in all organs of the entire body. That underscores how difficult the problem of correctly diagnosing brain tumors is.
So here basically the AI can be more effective than the actual physician and can be also more processive, because I guess
exactly I would say so. Based on the type of data that the AI took as the basis for this classification, this would have been completely impossible for a human neuropathologist to analyze completely different markers. So this was in a way a complementary approach, but I think what was, you might call it a ChatGPT moment, even though this happened a couple of years before ChatGPT appeared on the scene, was that we were certainly not the first ones to try to apply AI in pathology, but the efforts until that point looked like they would be okay for the simpler cases, for the routine pathology, but the more complex one would require expert human opinion.
But Bojan, if I could just come in a bit, I think you've raised a really interesting point that I'd like to get Lucia to comment on again. I think you're making a very convincing case and illustrating there that actually AI is becoming so powerful in its application here. It's doing a better, or will be able to do a better job than most humans. So we could see a situation where pathologists, doctors, are replaced by automated AI-driven tools. Lucia, how do you think society is going to cope with that? I mean, it's a different thing. I think I would feel differently if I went to the clinic and instead of having a human, I was just completely analyzed by a machine. Even if statistically I could understand it was more accurate, maybe I would still be a bit freaked out by that. Do you think that's something that society will be comfortable with?
Oh, I think some pockets of society will certainly embrace that. Maybe those who have more kind of literacy in that areas, and then the others will, still be afraid or will continue to have reservations, even if they have read up on it. So what we always say for anything really relating any kind of patient interaction is obviously that issue of proper informed consent, but also understanding the process. you know, it is really difficult, I think, at this stage to properly obtain that, or to speak to patients about those things, particularly if we are talking about collecting human samples, for example, for a technology that might not even exist in 5 or 10 years. So is that really informed consent? I guess, you know, the way that I would think that society would deal with it is to make sure, or even change the conversation with the patient to try and look at comparable technologies if they exist, to understand, you know, explain how those things might evolve, and to, you know, work with patient groups to properly talk to those patients to make sure they feel involved in the process, and it's not kind of just running away from them.
Maybe some fundamental concepts like informed consent have to be reevaluated in the modern era, the AI era, as to what that even means, or how it should be, how it should be implemented.
That's an interesting concept, and I know when it comes to, you know, the governance side and working with ethic committee decisions, there's a whole range of guidance out there about what you should accept in terms of consent. I mean, a lot of people say, you know, you shouldn't accept anything older than 5 years precisely because of that reason. But then, you know, how on earth do you regulate it or police it? Would we have to evaluate every single consent and make sure that all the technologies existed at the time? I think it would add a huge level of bureaucracy in terms of getting those projects through on a scientific perspective. So it would be tricky. I think that the easiest thing we could do would be, I guess, improve that consent phase, but also have a lower limit of what we'd accept in terms of consent form. You know, we don't accept things that are 10 or 15 years old anymore. That kind of thing would be a good start.
So I wonder what people think in general. Can AI have an ethical dimension? I mean, in clinical practice, one of the skills for a really good physician isn't just their accuracy in diagnosis, but what in English we call bedside manner. In other words, how do you interact at a human level? You may have the data that says, I'm really sorry you've got a brain tumor, but you want to find a way of, you know, empathizing with the patient and interact. I mean, that's part of the whole art of being a good doctor, a good physician. I mean, how do we see AI fitting into this? I mean, it can obviously maybe help to accurately find out hard facts. You do have a tumor, you don't, how much, you know, what are your chances? I wouldn't like to go to the doctor and have a machine just say, you are 93% likely to die because of this.
But what's the difference between the doctor going to his book and looking into a book and reading something, or going to the internet or asking some AI? I think, I mean, the reality is it is a tool. It's not replacing doctors. It is a tool that doctors can use to do better understand what's really going on. So I would really see them as tools. Also, as a programmer, I'm mostly doing programming, and it's a tool. It helps me to know things or find things that I don't know. It's a very personalized dialogue I have with the machine, and I think the same would be true in the area of health.
I mean, I think that's a key point, Michael. Thank you for raising it. The question is, can we keep it as just a power tool that just, you know, makes the doctors, in this case, a physician or a researcher or whatever, more efficient? Or could it go beyond that? Because already, you know, when people are talking about cost, you know, if instead of having a live doctor, you just get replaced with a totally automated system, maybe someone just argues, hey, it's more efficient, we can diagnose more patients faster, and so you replace them. But Alvis, you've got your hand up.
Yeah, it kind of maybe slightly a side point, but I would say AI can be actually better than humans to talking to patients. Yeah, we are already using AI to make our emails inoffensive and sanitize the text, yeah, make it politically correct. And we can train, I'm sure, these large language models to be very understanding of the particular patient, what he would want to hear and how to bring the bad news. So it's not necessarily to do with ethics, but I think when it comes to communicating, then AI has already proven how good it can be, in a sense.
Alvis, how do we know you're actually human and not an avatar?
But that's exactly the point. Yes.
Maybe we get to the point where that's less clear. But of course, in addition to images, it's also revolutionizing how code is written. And this ability to translate language directly into images is being paralleled by transferring language directly into computer code, which is another sort of language. Ben, maybe we could bring you in at this point, because I think you've got some nice illustrations of that.
Yeah, thanks a lot for the segue. So I'm a biologist by training, but I've been working on like computational biology research for a very long time. I did a postdoc at EMBL with Toby Gibson, who's retiring next week. So I'm going to be in Heidelberg, which is going to be very nice. So I, like many others, got very excited with AlphaFold when this came out, like about structure prediction from sequence. So, and since then, I've been getting more and more excited about what AI can do. And I think that Nush has a video that we could start with on GitHub Copilot, which is like a coding assistant. It's just kind of an ad for their very latest version that's not even out yet. So we can just watch that. It doesn't really have audio. But yeah, you can talk to it now. And it can explain very complex things to you. This is sort of really aimed at developers. But you give it faulty code, it can present a fix. It can also write tests. So if you've written a function that does a certain thing, it can help you, you know, like write something that tests it. So any change you make. Yeah, so, and it's integrated into a whole bunch of development environments. So it's really easy now to use this in workflows. And yes, it's getting very technical now. This is like web developer stuff. But this is the kind of stuff I think all of us that do some coding spend a lot of time Googling for. And this just kind of pulls it into where you actually do the coding, like your development environment, your kind of text editor. So that's very, very handy. And so I actually wanted to do a little live demo as well. I hope it's going to go well. The host has disabled screen sharing though. So maybe if we can. So
Stop screen sharing, right?
Yes, but it's disabled, so I can't share my own screen at the moment.
Okay, sorry, then.
So what I want to show is GitHub Copilot. This is actually kind of a little bit old hat because it came out about 2 years ago as a preview. It got commercially released last year. And so I'm just going to show how this Copilot program is implemented here. I hope you can see my proper screen. Is this readable? Like when I type something here? So can anyone read this? So just as a really simple example, I'm just going to say calculate the first 10 prime numbers. This is something we would normally spend some time thinking about. Oh, and you just saw it's actually giving credit here to a person who's actually using public code of GitHub, which is very debatable, like how ethical that is. So here's a function that, given a number, tells us whether it's a prime number, false or true. And now I ask it to do the first 10. So while numbers is below 10, we're starting at n equals 2. And we're just printing out all the ones that are prime. So that's a really simple example. And you know, I didn't have to do anything. Like all the code just popped up. When I press tab, it just turns my comment up here into working code. And the cool thing is it's trained on GitHub, which is an open source archive. All of that code is, like most of that code is licensed with an attribution license. So what they've done here is they've claimed fair use for using this code to train a language model, but it's actually very debatable. So a biological example would be like we have a sequence. And again, okay, this is actually being attributed. I haven't seen that before. That's interesting. So, so I'm just going to say we have this alignment. It has a couple of gaps, right? And it's even going to complete that for me. That's an amino acid here. So if we want to remove the gaps, it's just going to replace all the dashes with nothing. And I can also make it define a function for that. It's getting very codery. But it can give me a function and it can write me tests as well for this. Well, okay, it normally does. So I'll jump on to another example. If we want to get EMBL's latest blog post, this is something that I think even those of us that code a lot wouldn't normally know how to do without doing a lot of Googling. We're using Beautiful Soup, which is like an HTML text parser. It's going straight to the EBI, yeah, so this is going to request, like some kind of URL. We can obviously fix whatever we want to fix, like this address up here. And it's gonna, so now it's repeating itself, but it kind of works really well. That's what I wanted to say. And generally, you can also synthesize multiple solutions and choose one. And yeah, that's just what I wanted to show. So this really speeds up my own work in my experience, because, like figuring out what modules to use and stuff is normally a lot of Googling. And yeah, so I'm going to stop sharing there. This is it's trained on GPT-3, which is actually the predecessor of ChatGPT. Sorry, that is the model that is then fine-tuned to produce code. The video you saw, the marketing video, is going to be based on GPT-4, which is like the more powerful thing that's currently already driving Bing's search. So there's going to be be a lot more advances there. And the nice thing is that these models can also explain code. So if you give them code and you ask, what is this doing? How do I make it work better? It'll tell you, and it will suggest improvements. So it's really, really cool.
Something remarkable, Ben, is that, so we started Coffee with EMBL in, Noosh, was it in April 2020? I think that was the first one.
Yeah.
So just over 3 years ago. On that, and to be fair, we were rather preoccupied with coronaviruses at that time, rather than thinking about large language models. But just thinking back, I mean, how much of this existed then? Because I was not aware of any of these things. And if someone in the chat or the discussion in one of our first coffees with EMBL had said, oh, and in just 3 years' time, basically, you'll have automatic code generation, you'll have the ability to just speak and generate an image with photorealism, I would have been quite skeptical. So I must say, I'm interested for people also, perhaps you can comment, for people more directly in the AI field, was any of this as big a surprise to you as it was to me? And also, it feels like we're on an S-curve where things are just changing so fast. But what point are we on that S-curve? Are we still way down at the bottom? And things are going, so in 3 more years, a future coffee with EMBL, what are we going to be, seeing? What's going to be the capability?
Yeah, so in late 2019, I visited Stanford for 2 weeks, like on my Marie Curie fellowship, and I visited this machine learning lab that was applying machine learning to biological data. And they just kind of described the whole, all the AI papers coming out, they described it as like trying to deal with a fire hose of progress back then even. So nobody can really keep up with all the conference papers, all the new stuff that is coming out. And I think what we've just seen is a first really successful application of a large language model in ChatGPT. I think that's the first really useful one, right? The images are a little bit like toys, but ChatGPT is actually fantastic for learning about things sometimes, because it can explain things in very simple terms. So I think we're still at the bottom of that, like the beginning of the sort of curve going upwards, because this will find applications, it will be fine-tuned for different applications, and also larger models are coming out, better models. And I think, the quality of the training data is a bit of an issue, because this is usually like the internet, which is not known for being a hotbed for facts or good information generally.
Okay, we've got some questions from or comments from the audience. So just in the order I'm seeing them, apologies if it's not chronologically correct, but can I ask Alvis's avatar to comment?
Yeah. So I actually have a question to Ben, really. I must say this success of the code generation is, to me, the most surprising thing. And the reason is kind of ChatGPT is well known for hallucinations. Yeah, it can't get references right. Yeah, invents authors and I also, last time we had the coffee, I tested in some ways arithmetic abilities or mathematical abilities, and it pretty miserably fails on pretty simple things. Yeah. So how do you explain that it can't get references right, but it actually can write a code which actually is better than a human? So.
That is a very good question. I think the format of references is probably not working well for it, because if you look at code, I think it's still the sequence of things is still fairly stereotypical. But if you look at a reference, you really need to get it exactly right to reference that one particular article. Bing, the Microsoft search thing, so that one actually links to sources, but sometimes it bases its statements on things that are not given as a source. So even that one is quite terrible at attribution. I think it's just something that these models are not built for, because they process, it's like a reference, they would turn it into a couple of language tokens, like words. And then, you would really have to maintain the exact sequence to have a reference. And they're not very good at that. So I don't know if there will be a good solution for this. What GitHub Copilot does is it has an option to kind of compare the code it's generating for you against published code on GitHub. And you can tick an option that says, don't give me anything that exactly matches something that's been published. So that's like a very roundabout way of avoiding copyright infringement or licensing infringement. And that's definitely not a perfect solution yet. I don't know if there will be a perfect solution for this, unless we get new architectures somehow for these neural networks.
Okay, Michael, we'll take one more question. Michael, can you?
Yeah. So I'm using GPT to create applications, and one thing is ChatGPT is just one application of these language models. And what I'm working on is, and just recently, a few days ago, they announced something that's called functions. So you can train GPT to use programmable functions, like search the internet or do something very specific. And I'm creating applications for customers to access their internal data, their internal knowledge. So you can create internal databases and then use GTP to access the data from the databases. And they use something, or one can use something which is called vector data, which is it searches for data similar to your question in your database of data, and then give answers. Yeah. So the real point is ChatGPT is one very limited application, and people think, oh, it doesn't know the answer to this and that, but that's not the power of the language model. The power of the language model is being able, with this human level of language understanding, solve kinds of problems. Yeah, there are new papers recently out about something. It's tree of thought. So you have a strategy, instead of one-shot answer, you let GPT think about the question. Yeah, and what turns out, if the AI explain its steps of reasoning, it gets to better results. So people say, okay, give me 3 solutions to the problem, then evaluate which is the most promising. And then it tries this and goes down the tree, and then it might backtrack and try another solution. So there is a lot of movement and development in this area. And that's the one side. And the other side is, at the moment, there are these huge models like the GPT, but people are creating much smaller models with a much more targeted focus. I said in the comment, why do we need to know Shakespeare if we want to answer questions about biology? So the model knows all kinds of languages and all kinds of things, which is actually not necessary for specific tasks. And then with these smaller models, you can run them on your own PC or on your own,
own phone as well, right? They have specialized processors. Like since 2017, both like Google and Apple phones have had specialized neural network processors for matrix multiplication and stuff.
Yeah.
I would say though that Shakespeare will help you understand some of the weirder puns in paper titles.
So if I can jump in for a second, one thing that I was thinking about here is that you are actually now able to essentially speak with the machine. I mean, code is speaking to the machine, right? And this allows you to interact with the machine and probing complex information in the database. So one question that I had for Ben related to this, I mean, at which point, especially with coding, right, where the machine works by coding, essentially, this is the internal language. So at what point the machine starts to do a bit of self-coding into this? I mean, do we see application in which the machine is actually self-coding to refine these things, and then you can access that?
Absolutely, yes. So what I've done, like in my own coding, I've sometimes sort of asked ChatGPT for a first draft for doing some biological data analysis tasks. It gives me a first draft of code. Sometimes that doesn't quite work. So if I then tell it the error message, it will alter the code slightly. So it is definitely actively coding. Sometimes though, even with like 10 iterations of that, it still wasn't able to produce something functional that was doing exactly what I needed. So it's not perfect yet, but I think for some applications, it's getting very, very good. Like when you have a clear outcome, right? Like a clear test case for a function or something, then I think, so ChatGPT and Google's Bard both just got the ability to run code in the background. So they generate their own Python code in response to a question. So if you ask it now, like something that we've mentioned that they're really bad at is math. So if you ask a language model, what is 10,000 plus 2? Half the time it will not, I haven't actually tried this, but apparently they're terrible. And now though, those two, ChatGPT and Bard, Bard is able to generate Python code, run it, and give you the result.
Yeah, which I think, this is already different from last month, right? When Alvis was testing the logic and the mathematics, if the machine could just say, wait a minute, and then recode, then maybe...
Yeah, like let me do the calculation. Yeah, that's what it's saying.
But again, the key point is GPT is a model, and you can create applications that do that. They externally call functions to do things. ChatGPT is really a very limited application. I mean, the area of what you can do with these models is much wider than ChatGPT.
Yeah, no, certainly. And I think, this ties back to the argument also that, the general people are not learned to understand all of this, because a lot of people don't know what a large language model is. And even, people that are, quite educated will not know. And actually, I wanted to comment back on that and maybe made a little thought about that, which is, one of the fears is, ideally that the machine starts somehow to have a mind of its own into these. And so I think in a lot of these aspects, we were talking about the medical, right? That we want to have the human somewhere. Actually, I think there was a comment from Connor in the chat that maybe wants to comment about these when we were talking about, medical AI and the role of the doctor. I don't know if Connor is still connected.
Yeah, I'm still here. So, sorry, I didn't catch the question.
No, I mean, the question was simply, I mean, we were talking about the role of the human in the relationship with AI. You made a comment nice about the medical part, and I was trying to understand whether this is a general concern. How long do we need to still have humans in these, and where are we going?
I think it's until we start trusting them, really. But that's where a lot of the kind of fear comes into it. I think like the medical example is quite clear. Like I had a daughter who was very ill a few years ago, and if I imagined not having a human explaining that to me, that would be very deeply upsetting. I don't know how that would have felt, but having a person who could react was very important. And I think we are used to that human interaction, especially in those kind of scenarios. But I think, if you see the video of people thanking autonomous cars for stopping at pedestrian crossings and stuff, you think, well, we're made up of a collection of habits. And I think as we kind of get used to things, we kind of we develop new habits, and my children will probably have no problem with the concept of an AI doctor. They may even be quite scared of the idea of a human doctor because they are more fallible. And I think that's where potentially we're heading. I think a lot of the conversation in terms of using ChatGPT in, as an exciting thing, a lot of that comes across because we're used to the conversational thing. The thing that's made a big difference in the last couple of years is ChatGPT has made AI conversational and given it a kind of human tone. And we react well to the fact it's speaking in language we like, in language that sounds like, if you forget about the fact that it's a computer, it's coming from another human being. So that causes a different kind of reaction. But that technology, as was mentioned earlier, has been around for a few years. It's just developing better, more eloquence, and it's getting better from that point of view. But it is lacking that autonomy. So, like I think about 4 years ago, we had an abstract generator at the previous company based on GPT-2 that would generate, example abstracts for publications, and that was pretty convincing. And it's now evolved and evolved and evolved. But now the audience are getting kind of hooked into it more because of the fact it's more conversant. But that's leading to a massive expansion and things like LangChain and so on that are allowing us to use GPT type models and so on to then orchestrate lots of other AI and processes in the background. We use, say, GPT type models in order to generate Sparkle codes to explore knowledge graphs, so you can then interact with a knowledge graph using free text as if you're having a conversation. And it's these opportunities that are kind of making a lot of that technology more accessible to people. And I think as we see it more in day-to-day life, we'll get more comfortable with it.
So it's something to of course help people to essentially get better. I think one point to discuss maybe with Lucia is, but then if sort of the backdrop of the decisions are AI generated and sometimes not really understandable, where does the responsibility lies? This is probably, a general problem, right? How can you, maybe the AI is helping you making a better medical decision and you have to be the doctor delivering it, which is informed now by AI, but whose responsibility is if the decision is not the correct decision at this point?
Yeah, and that's precisely it. I think where does the buck stop really? And in terms of regulation, you need to really tightly control that. And I suppose what's linked into that too is also this idea of bias, which I know we've spoken about before in terms of AI. I was actually hoping to ask Ben. We've heard a lot about how those technologies have these built-in biases, and they have the potential, I guess, to shape social, cultural, economic structures. I wonder if you agree with that. And we always think about it from the ethical perspective. How can we prepare, I suppose, for to stop it reinforcing existing inequalities? Well, what can we do to mitigate against that? Do you think that's a valid concern that we should be thinking about on a research governance side?
I think that's absolutely true. And I think there are so many questions that are coming to a head at the moment due to the rapid scale up of machine learning. So like the GitHub licensing is one thing, right? So this has the potential of really upsetting the open source community. If people don't get credit for their work, they may decide to withdraw from this. So we may need funding mechanisms for open source. And more importantly, though, what you said, I put a link in the chat about Stable Diffusion's image generator. If you ask it for certain professions, it is much more likely to give you a certain skin tone and a certain gender than for others. And I think that is really problematic because those researchers found that the bias is even worse than the actual statistics. So I think that's something where we need to be very, very conscious in how these models are trained. And, so ChatGPT has its instructions that it sort of reads before it initiates every single chat. So maybe this is something that can be sort of, tossed over right now by at least just telling it, don't be too racist. And, but ultimately it's down to the training sets. I think maybe they need to be more consciously filtered and chosen. And And I think that it does need to be regulation. Many companies use AI for screening applicants, and I think even that can lead to certain socioeconomic backgrounds and classism. And so, yeah, definitely, I think the idea of having oversight as the European Parliament, I think, is now looking into, is a really good idea, yeah, and very necessary.
But I mean, a lot of this technology is coming out of a rather restricted set of Silicon Valley companies, and so it's tricky then, because the technology, we've just seen these amazing examples, it's so powerful. I can see it very quickly. We become totally dependent on it. It's like a drug that we think, because you can't compete without access to it. But then who gets to control access to it, and does it become a tool for manipulation at some level? You do what we want, you organize your society the way we want, or we switch off your access to it. How do we democratize that? I mean, that's for anyone actually to comment upon, but also in Europe, the European Union or individual governments, I guess, can vote whichever way they want. But what's their ultimate sanction, that they say, okay, we don't use this, and then their companies and their businesses can't compete on an international stage? It's a difficult thing.
I don't have an answer, but one thing that I can maybe comment on, which we were also discussing a bit in the last few days, is that maybe this acceleration, a little bit like the pandemics, is making us more aware, or becoming us more aware of these tendencies, right? You were saying this is in the end of few companies in the Silicon Valley, but the idea is that it has been for quite a while. Okay, the implications are so momentous that now we really open our eyes. But like other situation in history and in progress, perhaps we should have moved earlier on. We simply didn't realize. So I don't have a solution, but just a comment is that maybe it's not that bad. Maybe we will start to think about solutions.
Yeah. So in the chat, Thanos Genok. No, I'm sorry. I'm sorry, I didn't pronounce your song. We'll just say Thomas. Had also a good point, which we've been discussing a lot. Was nuclear energy good or bad, or is any technology good or bad? And my own view is essentially, for the most part, it's very neutral, but it comes down to, why did people develop it and what did they use it for? And as we've been discussing existential threats, or what can happen, I mean, I'm less personally worried at the moment, maybe wrongly, but I'm less worried about the machines taking over, that they just get together and decide to remove us. I'm much more worried about the motivations of certain types of humans who, given access to this technology, would deliberately want to program large language models with very negative thoughts or outcomes. I mean, I think we're fortunate, a lot of the companies developing this, OpenAI, I'd like to believe, have genuinely been trying to build in filters to constrain the technology and shape it in a way that is positive from our perspective. But there's no guarantee that you couldn't develop a model and train it in a very different direction. I don't know, Ben or anyone else, if you'd like to comment. I mean, what's to stop? I don't want, in an international forum, I don't want to point a finger at any particular government, but I'm sure we can all think of examples. I mean, if you, in an uncontrolled way, go out of, or just a criminal organization, does this make us more vulnerable to scams and deep fakes that steal our bank accounts? I mean, is that what we should be worried about?
Maybe if I can answer, yeah, I think so. Currently, these models are controlled mostly, like the very, very successful big ones like GPT-3, GPT 3.5, which is ChatGPT. They're all controlled by large corporations that only allow access to an API. You can't actually download the weights. I think for GPT-3 you can, but like for ChatGPT you cannot, and it's orders of magnitude bigger and more powerful. So at the moment, that's kind of the oversight, right? And I guess
but there are lots of open source models like Falcon or Orca that
Falcon
are
is
coming
academic
out.
originally, I think.
Yeah, and you can train them. But I think even if you have a model that is, so to say, ethically correct, there's lots of ways you can manipulate it to do bad things. Yeah,
you can fine tune
I think
it.
it's impossible. It's impossible to prevent that. Yeah, and even if you just fill the gaps yourself of the things, yeah, so they can help to do good and bad things. I mean, like it helps you to find maybe diseases. It can create diseases. Yeah.
Yeah. So Michael, I think, has a very good point. I see Connor has also his hand up. So maybe you want to comment.
Yeah, sorry, I forgot my point now. It's been a long day. Yeah, it was just looking at the, sorry, the brain's gone, got distracted by something. It's gone from there.
Okay.
But yeah, sorry, there's of course, all the GPT models are based on the data we make available to it, and that contains the biases of the society in which that was developed. So we're going to end up, when we're building models, we can't go through the internet and fine tune the internet. We have a certain amount of data that we make available. That means that those models reflect the bias that's in that data. It reflects the biases in society that creates the data. Now, we can then put controls on it. Some companies have put controls on it in terms of, say, adjusting for political bias and so on, and ethnic bias and so on. But in doing so, they are then projecting their own values onto those models. And they are then in a position where they're controlling the narrative and what's appropriate. And we're giving that power effectively to the companies who are building those models. And as has been mentioned, these models are becoming more and more democratized and more available for other people to access and build their own models. And yeah, I must admit, if I do have a fear, my fear with AI is the fact that it can be used because, unfortunately, the criminals generally move faster than legislation. So they will be looking at how they can use these things to extort money from our grandparents and from other people who won't know what to look for and all the rest. And looking at ChatGPT, all of us will struggle to tell the difference between having a conversation with a real person and so on. And I think that is kind of where the fear is. I think we are giving a lot of power to people. I'm not quite sure how you legislate against it, though, because the people you want to stop from doing it don't work within those rules.
Well,
I mean, sorry, Thomas.
No, I just wanted to make a stupid comment, but I think it's just a little bit of a joke. I mean, the stupid comment is that considering that this is trained on the internet bot, one big question is whether we are training artificial intelligence or artificial stupidity. And this is what some people also argue. But I just wanted to make an additional point because we are actually talking about responsibility or AI, because I saw a point coming up in the chat, which I think is very interesting. And this was, are these things sustainable? I mean, somebody, I think Yuri was commenting in the chat, and maybe he wants to jump in if he's still here, on, the energy consumption of these computations, right? I mean, can we have a sustainable world with so many humans and computation for everybody? I mean, this is an open question. I don't know if Yuri wants to comment or some of you want to comment.
Yeah, I mean, just from the perspective of a person running the compute infrastructure, I see the energy consumption of the GPUs that are running these AI things, even at EMBL, rising all the time. And we are not yet even a large consumer of these things, right? So if you look at the labs who are actually running AI 100%,
yeah.
Even Google is not able to deploy AI at scale because it's too expensive on the energy side. I mean, this is a real concern that we will have to address.
They are getting better and smaller and run in a few years. They will run on normal hardware like your phone or whatever. I mean,
I agree with that.
It's just getting we are in a phase, and training costs a lot of money. There were some papers just recently. Instead of millions, you can train models with a few hundred euros, which includes energy costs. Yeah, so it's getting better.
That's a reasonable projection. It's a reasonable projection to make based on the past 30 years of hardware development, but we are hitting the limits here. And what we will have to change is how we do compute.
Yeah.
And this will be a major change. That will be probably AI will start this change.
Perhaps I can make just a technical point here. I've read some proposals that one of the most immediately efficient ways of regulating who can use such powerful models and so on is to regulate the energy that their computing centers are allowed to consume. Because at least currently, this requires a lot of energy to generate these most powerful models. But as we heard, this may be changing rapidly as well. So it's another illustration of the rapidly changing landscape and the difficulty of adapting regulation to that.
But one would argue that this would be also a way to have another digital divide, right?
Yes, it's a difficulty with every regulation. Who determines what the rules are and who should obey them. And
it could benefit also places that have cheap renewable energy, right? Like solar power, water, like, so that's where you could have data centers that are carbon neutral. So there's a lot of mining involved and stuff, but yeah.
Yeah, Bitcoin is, just think about Bitcoin, the power that it is consuming.
I mean,
Bitcoin consumed as much power as Ecuador, the country. And Bitcoin is, in my opinion, the worst thing that humanity has done in the last decade or two.
Okay. There might be some discussion where it's really the very worst thing that's done, but you know, whenever the world changes, when we move to using fossil fuels to power locomotion and industry, we gave up horses. We completely gave a lot of politics and influence to countries that just happen to have big natural reserves of oil. And I guess this may be another seismic shift where the world changes. I mean, one last topic I think that I think it is really raised by these issues is, it was already touched on a few times, is liability. Where does liability actually reside? I think Connor was talking about self-driving cars. I mean, I'm absolutely confident that it will not be very long before you can prove statistically that an AI self-driven car has less accidents and is safer than allowing humans to drive around using their mobile phones, losing concentration, not looking properly. And statistically, it will just be, look, our world is much safer, but it won't mean there's no accidents. It will mean there's less accidents. But when an accident does happen, okay, then who's liable? Is it the person in the car who wasn't actually driving? Is it the company that sold them the car? Is it the programmer? Or maybe more in the US, where they don't have so much socialized medicine, but they're very used to, you know, for those people here from the US, it's part of the culture to say, I go to the doctor, if he or she makes a mistake, I can take you to court, and they have medical insurance because people will sue them. Who gets sued if the digital pathologist misdiagnoses your tumor? I mean, Ben, you've got your hand up. Do you have an answer?
I just wanted to say that I see that a little bit more positively. Like, I think the way that I've seen DeepMind propose of applying like tumor, like detection, like kind of pathologist, like supporting pathologists, was that, the pathologist looks at it first, and then you flag up anything that hasn't been spotted that might be metastasis or a tumor. So I think I think it could be used in a very positive way, as long, and like I think they showed that the worst pathologists like underperformed compared to the AI, and some of the best ones outperformed it. But you could lift up the ones that are not performing too well, or that are having a bad day. So I think there is a lot of hope there. What I wanted to say though is that the whole car thing is very much like when you have a hammer and everything looks like a nail, because the alternative to self-driving cars is simply having public transport, right? Like trains, like that is a self-driving thing. And I think we could make our lives a lot easier by expanding that.
But then you have a self-driving train. I mean, you already solve part of the problem if you have one.
It's in a controlled environment.
So. Yeah, but Boyan, you have your hand up.
Yes, perhaps linked to the pathology. First of all, I would like to say that this was something I was referring to when I was talking about the ChatGPT moment, because what Ben was mentioning, there are systems which outperform the worst pathologies, but they're not as good as the best ones. Whereas the system that I talked about, this actually proved out to be more correct than even the top experts. So in about 15% of the cases, the system gave different diagnoses to the top experts. And when these people re-reviewed their cases, in most situations they actually agreed with the AI, showing that we have already systems that are proven statistically in pathology to be better than the top expert, not just the most humans or most pathologists, but the best pathologists. And in fact, I think you were talking about statistics becoming available soon. I read a few years ago statistics showing that self-driving cars are better than the average human driver, safer than the average human driver. And maybe also about the issue of who takes the responsibility and who gets sued. I mean, I did exit the institute or the field, let's say, of neuropathology a few years ago, but the way this is handled, this was handled then, and to my knowledge is still handled, is that it of course remains, so the AI tool is just a support and an addition to the standard pathology, and it's the pathologist who takes responsibility of the final decision. I'm not aware of any trends at the moment to completely relegate the responsibility just to the AI system. It's just, I think, a supporting tool.
I think legally, at least in Italy, they have to sign, and also they have to inform, which opens up all this field of explainable AI, where you need the algorithm to at least explain itself for it to be understood by whoever runs it, so that you can pose question and this, you know, then the physician or the legal representative of the hospital can say, well, the algorithm has taken this decision because of da. The doctor agrees with that and he signs, and or she signs, and then you can sign here. So I think that the flow, I think, is this one, because unless the law is changed, you know, it's law.
Yeah.
Yes.
Yeah. Nush, I'm aware that time's getting on. We've covered a lot of ground. With still quite a few people online, I'd be very interested if we took our vote again and just see, do we have any evidence of any shift in, are people more concerned or not? So please do vote again and see if we have any difference in the outcome.
I'll share it in a minute. I'm waiting to see 31 people have voted, so I'll give it a bit more.
Yeah, we can show it right. We can conclude with the outcome for that. But I think whichever way the poll goes, I think it is interesting that there are so many ways in which we can see our society changing. I think it's also really hard to evaluate some of the implications because the technology itself is just moving so fast. And it does worry me that, the legal systems we have are not generally designed very well to cope with such fundamental changes in how things operate. I wonder how many of our politicians who vote to create the laws and regulations themselves actually understand the technology. So I think it raises, a lot of important challenges for us to consider. I think there's a lot of interesting issues around liability, also ownership of things. Who's got creative ownership if I simply say, oh, paint me a picture that looks like X, and it suddenly becomes, well, what is that my picture if it was really made by Stable Diffusion? I guess it is. I don't know.
I'll share the vote because it's 46 out of 50. So I will.
Okay.
And share.
Drum roll. Wow. It dropped.
Yeah.
It did.
So either a lot of positive people left early, or else we really started to alarm some of our friends and colleagues about the issues here.
Yeah.
I think the energy dimension might really be new to some people, because I think that's something, certainly Yuri would probably agree that computational biologists and bioinformaticians have traditionally really liked keeping the cluster busy and running as many jobs as they can and as large as they can, just because it's tempting. And I think maybe it's really time to think about the impact of that.
Yeah, I would agree. I think, again, this has been, for me, a really enjoyable and stimulating afternoon or evening or morning, depending on your time zone. I've really enjoyed it. I think that we are, you know, a really great community that I thoroughly enjoy interacting with. And I think this is a great forum for bringing people together and exploring these ideas and learning from each other. So thank you once again to everyone who participated. We look forward to hearing from you and to seeing you again very soon. So thanks once more, and bye-bye.
Bye-bye, everybody.
Thank you.